Hello everyone. Let's discuss about frequently asked questions from carbohydrates. So the very first question I am discussing here is a chemical reaction of glucose. If we just check the open chain structure of glucose, it has 6 carbon atoms. So a question that one is asked, with the help of a chemical reaction, show that it contains a 6 carbon atom in a straight line. So we do this with the help of an HI, which is a powerful reducing agent. With the help of HI, glucose changes into N-hexane. So the formation of N-hexane shows the presence of 6 carbon atom in glucose which in a straight line. Next, with the help of a reaction, show the presence of carbonyl group in glucose. For this purpose, we do a reaction of glucose with hydroxyl amine. Carbonyl react with hydroxyl amine, resulting in the formation of oxime by loss of water. So this result in the formation of oxime here. CH double bond NOH, CHOH4, CH2OH. Or you can also show the presence of presence of carbonyl group in a glucose with the help of a HCN. This result in the formation of cyanohydrin. Carbonyl react with HCN to form cyanohydrin. Then the next part, with the help of a chemical reaction, show the presence of the presence of aldehyde group in a glucose. So for this purpose, what we do, we react a glucose with a mild oxidizing agent, bromine water here. This result in the formation of gluconic acid. CHO changes to COOH here. So the resulting gluconic acid is formed here. Gluconic. Rest of the structure same, only the terminal CHO part changes into a COOH part. Next, with the help of a chemical reaction, show the presence of 5 alcoholic group in a glucose. For this purpose, what we do a acetylation reaction with the help of acetic anhydride here. This result in the formation of pentaacetate derivative of glucose. Pentaacetate derivative. Then with the help of a chemical reaction, show the presence of primary alcoholic group. So for this purpose, we use a dilute nitric acid, which is a bit stronger oxidizing agent than bromine water. Because of the dilute nitric acid, CH2OH group also changes into the COH. CHO changes to COH. Along with this, primary alcoholic also changes into a CO. This result in the formation of saccharic acid. So with the help of these reactions, you are able to detect whether it has a 6 carbon atom, it has a carbonyl group, it has a CHO group, it has a 5 alcoholic group, and a presence of primary alcoholic group. This one is the most important 3-marker question from a glucose. Another category of question which is frequently asked from carbohydrate is a hydrolysis product, glycosidic linkage, and whether the resulting carbohydrate is a reducing sugar or a non-reducing sugar. So let's start with the sucrose here. Sucrose. It is a oligosaccharide. It is a basically disaccharide. On hydrolysis, it produces alpha glucose and beta fructose. Levo rotation of fructose is more than that of the dextrorotatory glucose. That's why it is also known as a invert sugar. Inversion of configuration takes place on hydrolysis. Then the type of glycosidic linkage. What is a glycosidic linkage? It is basically an oxide linkage between two monosaccharide units. So in case of sucrose, C1 carbon of glucose form an oxide linkage with C2 carbon of fructose. The resulting carbohydrate sucrose is non-reducing sugar because C1 carbon of glucose is carbonyl aldehyde, C2 carbon of fructose is keto group. Both these carbons are involved in a glycosidic linkage, so it doesn't have a free carbonyl group. That's why it is a non-reducing sugar. Next is a maltose. Maltose is a disaccharide. As on hydrolysis, it produces 2 units of alpha glucose. In this case, C1C4 linkage is there. C1 carbon of one glucose connected with C4 carbon of another glucose, and the resulting is a reducing sugar, because the second, if you just check the second glucose, its C4 carbon is involved in a glycosidic linkage, not a C1. So it means it has a free carbonyl group. That's why it is a reducing sugar. Next is a lactose. If you just check a lactose here, lactose is a disaccharide. On hydrolysis, when you add water to the lactose, it changes into a beta galactose and beta glucose. In case of lactose, there is a C1C4 linkage. C1 carbon of galactose, which is a carbonyl carbons, form a oxide linkage with a C4 carbon of glucose, which is a non-carbonyl carbon. That's why lactose is a reducing sugar. Next is a starch. Starch, that one is a polysaccharide, because on hydrolysis it gives n units of alpha glucose. This starch, that one is further classified as amylose and amylopectin. Whether that is the amylose part or the amylopectin part, both are non-reducing sugars, and starch is also non-sugar because of it is not sweeter in taste. Then next is a cellulose. Cellulose, that one is a polysaccharide. Why it is a polysaccharide? Because on hydrolysis, it produces an unit of beta glucose. In this case, C1C4 linkage is there. It is a non-reducing sugar because it doesn't have free carbonyl group here. Then is a glycogen. Glycogen is basically, its structure is similar to that of amylopectin. It is also known as animal starch. It is present in liver, muscle, and brain. Starch is further classified as amylose and amylopectin. Amylose is a linear structure. It has a linear structure, whereas in amylopectin, it has a branched. Amylose contains 15 to 20% starch, whereas amylopectin, it contains 80 to 85% starch. Amylose is water soluble, amylopectin is water insoluble. Then the most important question asked from the amylose and amylopectin part, a glycosidic linkage. What is a glycosidic linkage? It is an oxide linkage between a monosaccharide units. So in case of amylose, there is a C1C4 linkage, which is result in a long linear chain of glucose. Whereas in case of amylopectin, along with this linear linkage, there is a branching between the two layers. That one is a C1C6 linkage.